Let's take a look at Microchip Technology's new kit for extreme low-power application development. The XLP 16-bit development board provides a low-cost, highly configurable development system for Microchip's new line of extreme low-power 16-bit PIC24F microcontrollers, which feature sleep currents down to 20 nanoamps. This board enables users to explore and evaluate extreme low-power features available on PIC XLP MCUs while learning a variety of low-power software and hardware techniques. Various headers are available to measure power consumed by the PIC MCU and other board components. The board is flexible. It can be powered by over 5 sources, including energy harvesting modules, and supports a variety of common components that can be selectively enabled. It is also expandable. The provided pigtail accessory connector permits the addition of capabilities such as RF connectivity via accessory boards. The board supports a wide voltage range from 1.8 volts to 5.5 volts. Let's look at the 16-bit nanowatt extreme low power XLP development board features in detail. There are sockets provided for 28 and 20-pin PIC24F K and J family of XLP MCUs. There are 6 different power source options allowing you the ability to configure your operating voltage between 1.8 to 5.5 volts. These power sources include 2 AAA batteries or a coin cell 2032 battery, a fixed power supply, USB power, a variable DC power supply, or an energy harvesting power supply available from our partners. 2 temperature sensors are available on the board. Microchip's MCP9700 temperature sensor, or a diode that can be used in conjunction with the charge time measurement unit peripheral module available on the PIC MCU for temperature measurements. A potentiometer on the board provides analog voltages that can either be input to the analog to digital converter module on the PIC MCU or used as a reference voltage for a high-low voltage detect circuit available in the PIC MCU. There are 6 buttons, 3 capacitive touch, 2 push buttons, and a master clear reset switch for the PIC MCU. There are 2 LEDs. USB connectivity is available to connect the MCU on the board to a host such as a PC via a UART to USB bridge circuit. There are also 2 available RS-232 transceivers, though these are not populated. A reduced pin count pigtail connector allows you to expand the board to add features such as an RF, Ethernet, speech, SDMMC capabilities via a separate pigtail board available from Microchip. Power disconnect jumpers are provided to selectively disable features on the board and components such as the potentiometer, the RS-232 transceiver, pigtail accessory boards, and the serial E2PROM. You can use a switch to control power to board components with a port pin on the MCU if you choose. By default, these components are powered by VDD on the board. Firmware to the onboard PIC MCU can be programmed or debugged using Microchip-compatible programmer or emulator via the standard RJ11 in-circuit serial programming connector. There is also a 2-pin through-hole socket for voltage, capacitance, and time measurements that is provided on this board. On initial power-up, the development board works as a demonstration board. The included demonstration software takes a temperature measurement, data logs the information to an onboard serial data E2PROM chip, and displays information to the PC via USB port. Additional software is also provided to demonstrate low-power techniques and IC interface routines. Headers are provided to measure PIC and component current consumption, which we will demonstrate right now. You would need to take an ammeter cable and connect it to the header so you can measure the current on an ammeter. You can purchase the XLP 16-bit development board from Microchip or our many distributors worldwide. We hope you're on the way to enjoying XLP application development. To learn more about extreme low power application development and Microchip's PIC XLP MCUs, visit www.microchip.com/XLP.